062O_M20_Ms_42. 2 Aluminium is extracted from its ore. The ore is converted into pure aluminium oxide, which then undergoes electrolysis as shown. A. Name an ore of aluminium. Bauxite 1. E. What is meant by the term electrolysis? Breakdown by the passage of electricity 1. Of an ionic compound in molten aqueous state 1. B. Aluminium oxide has a melting point of about 2000 degrees Celsius, but the electrolysis process operates at about 900 degrees Celsius. I. Name the compound added to aluminium oxide to reduce the operating temperature. Cryolite. E. Suggest one benefit to the environment of reducing the operating temperature. E. Write the ionic half equation for the reaction taking place at the negative electrode cathode, the positive electrode anode. IV. Explain why the anodes need frequent replacement. Anodes are carbon graphite react with oxygen O2 1. Form carbon dioxide 1. C. Aluminium oxide reacts with acids and with alkalis. I. What term is used to describe an oxide that reacts with acids and with alkalis? Amphoteric. E. Aluminium oxide reacts with dilute sulfuric acid to form a salt. State the name and write the formula of the salt formed. E. Aluminium oxide reacts with dilute sodium hydroxide to form a salt and one other product. Name the other product. Water. IV. Aluminium hydroxide, AlO3, decomposes when heated to form aluminium oxide and water. Write the chemical equation for this reaction. V. Suggest the names of 2 other aluminium compounds that decompose when heated to form aluminium oxide. 2. CV. Aluminium carbonate 1. Aluminium nitrate 1. 0620_S19_Ms_41. 3. Zinc and copper are elements next to each other in the periodic table. 8. Zinc is obtained from zinc blend in a 2-step process. Filled circle in step 1, zinc blend is converted into zinc oxide. Filled circle in step 2, zinc oxide is converted into zinc in a blast furnace. Outline how each of these steps are done. In your answer, filled circle give one chemical equation for each step. Filled circle describe how zinc is removed from the blast furnace in step 2. B. Name the alloy formed when zinc is mixed with copper. Brass 1. C. Copper is a transition element. It can have variable oxidation states. State 2 other chemical properties of transition elements which make them different from group 1 elements. 3. C. Form colored compounds ions 1. Act as catalysts 1. D. A compound of copper can be used to test for water. I. State the full name of this compound of copper. Anhydrous copper 2 sulfate 1. E. State the color change that occurs when water is added to this compound of copper. From white 1 to blue 1. E. Aqueous potassium iodide reacts with aqueous copper 2 sulfate to produce iodine. E. Deduce the charge on the copper ion in Qi. 1 + 1. E. In terms of electron transfer, explain why copper is reduced in this reaction. Gains electrons. IV. Identify the reducing agent. 0620_S19_Ms_42. 7. 8. Displacement reactions occur between metals and metal ions. Displacement reactions can be used to determine the order of reactivity of metals such as lead Pb, nickel Ni, and silver Ag. The ionic equation for a displacement reaction is shown. The ionic half equations show that electrons are donated by nickel atoms and accepted by lead ions. I. Identify the reducing agent in the displacement reaction. Give a reason for your answer. Reducing agent. Reason. M1 Ni nickel 1. M2 it loses or donates electrons 1. E. What is the general term given to the type of reaction in which electrons are transferred from one species to another? Redox 1. B. The ionic equation for another displacement reaction is shown. Write the 2 ionic half equations for this reaction. C. Use the information in A and B2. Put the 3 metals lead, nickel and silver in order of reactivity. 7. C. Most reactive nickel Ni. Lead per petabit. Least reactive silver Ag. D. Nickel is a transition element. Nickel is stronger than sodium. Describe 2 other differences in the physical properties of nickel and sodium. Nickel has M1 higher density 1. Nickel has M2 higher melting point, boiling point 1. E. Predict one difference in the appearance of aqueous solutions of nickel compounds compared to aqueous solutions of sodium compounds. Solutions of nickel compounds are colored 1. F. Copper is refined purified by electrolysis. Nickel can be refined using a similar method. I. The diagram shows the refining of nickel by electrolysis. Complete the labels in the boxes. M1 electrolyte aqueous or solution of named nickel salt 1. M2 anode impure nickel 1. M3 cathode pure nickel 1. Indicate, by writing N on the diagram, where nickel is produced. Nickel produced at cathode under the liquid surface 1. 0620_S19_Ms_43. State, in terms of the total numbers of electrons, neutrons and protons, 1 difference and difference. M1 number of neutrons. Similarities. M2 number of protons. M3 number of electrons. B. All isotopes of magnesium react with dilute hydrochloric acid to make hydrogen and a salt. Why do all isotopes of magnesium react in the same way? M1 same number of electrons. M2 same number of electrons in outer shell. Write a chemical equation for the reaction between magnesium and dilute hydrochloric acid. Describe a test for hydrogen. M1 test. Lighted burning splint. M2 result. Squeaky pop. C. Magnesium is a metal. Describe the structure and bonding of metals. Include a labeled diagram in your answer. M1 lattice of positive ions cations. M2 delocalized sea of electrons. M3 attraction attract between positive and negative. D. Magnesium reacts with oxygen to form the ionic compound magnesium oxide. Complete the dot and cross diagrams to show the electronic structures of the ions in magnesium oxide. Show the charges on the ions. M1 magnesium ion. Second shell shown containing 8 electrons shown as X. M2 oxide ion second shell shown containing 8 electrons, 2 as X and 6 as M3 charges. Magnesium ion is 2 plus and oxide is 2. Magnesium oxide melts at 2853 degrees C. Why does magnesium oxide have a high melting point? Strong forces of attraction between oppositely charged ions. Explain why molten magnesium oxide can conduct electricity. Ions per megagram 2 plus and O2 and ions and cations can move throughout the structure.